Scott, I think we are now with you, right? Let's go.
Yeah. All right, well, we're going to switch gears a little bit, and I'm going to speak up loudly because I know all the people in this room are very interested. I'm going to work on de-identification of student writing in technological mediated educational settings. This is work that I've done with my PhD student, Langdon Holmes, and actually a professor here at UPB. So our interest with de-identification is basically the idea that we have massive open online MOOCs courses that are popular platforms that are being spurned every day. They allow for a greater enrollment and more diverse student populations. And we're collecting a huge amount of educational data on these platforms. And that data can be used to solve problems, address solutions, come up with puzzles and come up with interventions to help students learn better. And much of that data is going to be forum data, which is basically where students themselves write data into either forum posts, discussion posts, and sometimes into assignments. And this data can be very valuable. A major problem with all this data is personally identifiable information, so PII. It is everywhere in educational data. And in order to produce open data sets, which is what we always seek, data needs to be anonymized. But this is absolutely a non-trivial problem, especially for automatic systems. And so we're looking into the potential of using something called named entity recognition, basically powered by pre-trained transformers based on large language models to try to identify personal identifying information in large educational data sets. And this is a massive problem, I think, throughout the world, but also especially in the United States, where students' personal identifying information is protected. And the release of personal identifying information could be very dangerous to the students, the family, and to education at large. So this is what personal identifying information looks like. We can, of course, have names. Students can put in phones or numbers or IDs, locations, or even affiliations. And we need to be able to annotate, classify, and try to remove this information. We're going to really focus on names here. All right, so this is our data. We have a large online course called Design Thinking for Innovation. It was sponsored by University of Virginia Darden, which is their business school. It was hosted on Coursera, which is a very popular learning management system. And it was a short course. It was only about 6 hours. And they had one graded assignment. The students had one graded assignment that was peer reviewed in the end. Even though it's a short course, there was almost 400,000 users. About 10%, 40,000 of them completed the course. There was about 220 assignments that were submitted that led to about 28,000 basically assignments that we could parse through. And they also had discussion forums, and there was a discussion forum specifically for this one graded assignment, and there was about 3,000 users in that discussion forum. So this is a little bit about the students. You can see most of them are from India, followed by the US and Nigeria. And we try to figure out what their most common language was, or the language they're using, by looking at their browser languages. And most of them are speaking English or using English settings in their browsers. So all students had to submit an assignment, and the purpose of that assignment was to apply some design thinking strategies to a problem. This is an example assignment on the right as shown, basically talking about storytelling and how it can be used to apply it to design thinking. Students were required to peer review 3 other assignments, and then they gave an analytic rubric on 6-point scales to basically provide scores to these assignments, and that's what led to students either passing or failing the class. All right. The assignment events were all in an SQL database. Luckily, they all had some type of URL, user ID, timestamps, final score, some additional metadata like that language data, and keys to other tables. But all submitted files, so the assignments themselves, were submitted in PDF format, which makes it very hard to parse. So we said it was started with over 220 assignments, which is a lot. We had 36,000 of these assignments where the user had precisely 1 scored submission. So we only focused on those 36,000 because we don't know which other assignments were going to be basically copies or revisions or final drafts. In the end, we ended up with about 32,000 assignments that we were able to download, and then we only selected assignments, about 28,000 that we could open in PDF that were at least 5 pages long and had at least 50 or more words, and they were written in English. So we had a program called CLD2 that detected what the language was that the submissions were written in. So in the end, we had these 28,000 assignments. They were collected between 2016 and 2022. The mean word count per assignment was 678, and the standard deviation was 286. So these are pretty long assignments. Now we wanted to go through these assignments, and we couldn't go through all 28,000 because that's just a lot of assignments. But we had to collect human labels for all of the information. So we selected basically about 6,000 texts that were labeled by 2 annotators. They were undergraduate interns. They're the 3rd and 4th authors on this paper. Each document was labeled by 1 annotator, and we used something called Docano, which you can see on the right, where you basically highlight an item in a text, and then you say, oh, this is a person, this is an other, this is a company, all the way through. So for our label PII in our 6,000, more or less 6,000 assignments, we had about 1,500 student names that popped up. We had about, I don't know, it looks like 200 that were company names. We had fewer emails and fewer locations that popped up. So mostly it was student names that we needed to clean up. So the data in a long nutshell is this: we got about 6,000 labeled assignments, which is about 23% of overall data. Remember, because we had about 28,000 texts. We used 2,500 of these in training. We used 800 of them for validation, and then we used about 50% of them as a testing set, because we wanted to be able to go through these texts and these assignments and automatically annotate each one of them for potential PII, so that eventually we can have some system where a computer or machine can go through and hopefully annotate data, clean that data up, and make that data usable and shareable throughout larger language and testing and learning communities, so that we can develop new interventions and new theories about learning. We use something called named entity recognition models. There's a very popular NLP package called Spacey. We use the named entity recognition in Spacey. That basically detects all persons' names. It's not going to be terribly accurate, but then we fine-tuned it to detect student names only. So as I mentioned, Spacey is an NLP processing engine for Python. It's a sequence classifier, so it will classify tokens or sequences of tokens, because names are usually not just one single name, but might be 2 or 3 names, and it'll classify those as named entities. And then we basically consider all sequences labeled as persons to be potential students' name, and we did some fine tagging on those students' names, specifically to look at sequences. And we wanted to reward the model for recall, because we're not too worried about it if it gets something wrong, if it's a precision wrong, but we want to make sure that we're able to recall every single piece of personal identifying information in that text. So we sacrifice precision for recall. Here's an example of what happens. Spacey and our NER will say, hey, this Mr. Bello appears to be a name. The fine tune will say, oh, Bello Senior seems to be a name. So we'll combine overlapping sequences into one labeled sequence, which would be Mr. Bello Senior. We used basic precision and recall to look at our model evaluation. We use what's called an F beta measure, which gives more weight to recall than precision, because again, we want to try to classify and annotate every single potential student name in there so that we can remove them so that the data can be shared. And then we did a post hoc analysis of model errors. We were only able to do this on one of the annotators so far. We're working on the second annotator. All right, this is our results. We do pretty well. So what we're looking at here is the true positives. We want to get as many of those correct as we can. Notice that we have a whole lot of false positives. We have fewer false negatives. We have no true negatives here because the names are a variable length, so we couldn't really define how many sequences there are. Our recall was 93%. That means of those annotations for names in the data, our system was able to classify 93% of them. We're still losing 7%, which is bad. So we still got a little bit of work to go, because I guess the idea is that one poison drop in the larger lake will poison the entire lake. So we want to make sure that we at some point reach a recall of 100%. Notice that our precision is quite low because we're bringing in a whole lot of false positives and false negatives, and our F beta isn't great. This was the evaluation of the errors in the test set. We had some example of false negatives, false positives. These are some false positives that we had. Some of this was because our annotators missed names, and some was because they're just like a name like Roland Barthes, who's a famous author, shouldn't be considered a student name, or something like Geoff. This was the name Geoff was actually in one of the readings the students had, so a lot of them referred to Geoff. So most of our problems were with names that did not clearly refer to a student, like historical names or place names. All right, so in conclusion, we have a fine-tuned NER system that achieves about 93% recall, which is pretty okay. Precision was quite low, but that's okay. Think about this as basically if you're trying to detect cancer in patients, it's okay to tell some patients, hey, you might have cancer when they don't have cancer, but you really want to get the patients that have cancer and tell them that they do have cancer, so you can start working on solutions to that. We think the results are relatively positive and promising, but further work is needed because any leak of PII could impact the integrity of the system. We're hopeful that we can focus on developing this so we get close to 100% recall, so that we can share large stores of educational data publicly. And in that way, we can help develop tools and interventions that maximize learning and promote open science. So limitations, obviously, low precision. Our approach requires labeled data, which is labor intensive and difficult to do. Our recall was not perfect, and we were only looking at names here, but names are probably the most important part. Our next step is to continue with our human annotation so that we have a larger data set available. We want to fine tune our NERs a little bit better, and then we want to use those annotations to label the data, evaluate the data, and then remove or obfuscate the PII. And then we want to be able to share that data with everyone. So these are some initial attempts we've worked on to identify PII in student data automatically, because this is a very time-intensive, resource-intensive task. And we're hopeful that we can be a little more successful so that we can start releasing very large data sets to the community and to the public, so that folks can start using those data sets to develop educational interventions that assist and help all students. So thanks. If you want to work with us, those are our emails, and I'm happy to take any questions.
I have a comment. Maybe, I don't know if you were listening to the first invited speaker, Philippe Dessay, about CAC. And actually, I think that this is the way, in the sense the one that you present is the right way. I mean, not just do not use the data or obfuscate data, but try to identify the data. That is actually what you should do. Otherwise, it's impossible to really provide any personal learning process, etc. So we do really need the data like those there. And apart this comment, my question is, do you also try to operate the identification on other categories of data, or only on writing XA?
Well, currently we're looking only at written assignments, but we would like to move into, our next goal is also to move into these forum posts, because the forum posts contain a lot of personal identifying information as well. We're hopeful that there won't be much difference between kind of the forum posts and the written data. We're not in any position right now to start working with spoken data or maybe video data or anything like that. So this seems like kind of, I wouldn't say it's low-hanging fruit, because it's definitely not low-hanging fruit, but it is probably the easiest type of PII to identify in written data using the existing tools that we have at our disposal.
My concern, Scott, actually, you in your when you were sharing with us your results, you took at a certain point, you took my concern completely out of focus, because in these kind of systems, as you mentioned, there's no margin for error. It has to be 100%, because this gets into very critical and serious issues, and well, institutions can be sued for this, teachers can be sued for this, and so it can get very serious. So this is the kind of automation process that has to be 100% fine-tuned, And another, so there in your results, you clearly stated that yes, this is our goal. There's no other way of doing it in these kind of systems. And the other issue, it's related with what Carlo is saying. We are living with some time with a generation which is really multimedia generation. So I know you are focused on the written assignment. We still have a lot of that around, fortunately, and hope it will be around for much more time. And also the interaction and communication, synchronous and asynchronous. Considering multimedia content, we also have a lot of photos, a lot of images, a lot of print screens, and of course also short videos and animated GIFs and stuff like that starting to go around. When we go into that field, there it will be difficult. Most probably you'll have to leave all that content out. It will not be in the bundle to be shared. I don't know, it's just your quick opinion on all that and your experience on all that other area, which is really also in all this, as we know, multimedia content, of course.
Yeah, I mean, I honestly have no experience
Oh, okay.
with multimedia. I'm always shocked when I talk to my students about things like this, because my students readily share everything about their lives on Facebook or Instagram, and they're not too terribly concerned about PII. But we are. And so there is, I don't think that's going to change. I'm assuming that institutions are always going to be worried about the release of personal identifying information, but I really don't think the students are nearly as concerned as the administration, the institutions, and the older generation that we are about releasing information.
Oh, it's Yannicka. Okay, Yannicka.
Yes. Okay. So I would like to ask that when we discuss with companies about their cloud-based services, they have to share this and that, what will happen to your personal health data and so on. But what if we could implement a similar approach in education? So before I start using MOC, there will be the new logic of disclaimers that most likely your data will be used for research, so it will be used as an open data, and also in disclaimer to point out that whether you give us right or you just shouldn't use this and that, so just transfer a bit of responsibility also to the student, and I can already imagine what would happen if you force me to study in this MOC, how you dare, or can you elaborate a bit on that, what if we say what is going to happen, what it is?
Yeah, and I should have mentioned this, what you said is very important. So this data set, UVA, the students were given, they were told, like, this data will be made publicly open unless you opt out of it. And the students that we're using right now are only those students that said, like, I agree to have my data used publicly. But it becomes a little more difficult when you're looking at young children who can't always make those decisions, and those parents can't really make the decisions too. So with adults, it's a little different because you have kind of responsibility and you can make decisions that, can influence who you are. Children are a little more different. You did also potentially bring up a good idea that a lot of people work on, and that is the idea of data enclaves. And data enclaves are the idea that all of this educational data is behind a firewall, and you can write programs to access it, but you never actually see the data. And then whatever program behind the enclave will run your data analyses and give you the results. And that's another sort of solution to this PII problem. But it requires a lot more expertise and computer science backgrounds, and it's a lot more complicated to develop and implement. So, yeah, but those are important ideas.